For those I haven't met, I'm Darryl Purificati. I'm Senior Technical Advisor for OEM Automotive for Petro-Canada Lubricants, HF Sinclair, representing the Petro-Canada Lubricants brand. What do I do? Well, I do product support. I do for light duty and heavy duty. So it's all of our product lines supporting our sales staff. I am a liaison between sales, what's going on in the real world, and our R&D departments, our marketing department, what people are looking for, and the guy who kind of relays some of that message. And then a big chunk of my job is as the Petro-Canada representative on API, for API. So all the API committees, the American Petroleum Institute, everybody know of API, heard of API? Well, as we go through it, you'll recognize it, but the little donut on the back of the bottle that shows kind of the category and whatnot. Those categories are being developed through American Petroleum Institute. We're going to talk a little bit about the next category that's coming up eventually. So API and category background. API was founded in 1919, so it's been around for a long time. Shortly after, they started developing some standard categories. So if you're familiar with API SP on the light duty side or API CK4, those started with SA and CA all those years ago. And over the years, they've progressed and every new category gets a new letter. Occasionally they skip a letter. There's no SO because there's too much of a commercial name in Canada. So their SK is another one. There's a few categories that have happened where they've skipped the letter for various reasons, but the S categories for spark ignited or service category, the light duty side, and the commercial side or compression is the C categories that you know for the heavy duty categories. As the categories go through, they're not all still active. Many of them are obsolete. Nobody can buy a CE oil anymore or a CD oil, a CF2 or any of those. They've been obsoleted for various reasons. So there's 4 current categories. CH4, introduced in 1998. It's old technology, but it's still found in various geographies in the world. CI4 was introduced in 2002, CJ4 in 2010, and CK4, which everybody is familiar with today's, was introduced in 2017. Those are the active categories. So how does a category get developed? Anybody can submit a request for a new category. Anybody. So if Utah feels like there should be a new category, you can submit a request to API for evaluation of a new category. Generally speaking, that's not how it works. However, that is the basic concept of how it can be introduced and a category begun. Generally speaking, what happens is the auto manufacturers find a reason or a justification, or they've got heads up on a lot of things that are going on, and they come to the industry and say, we need a step change here, because if not, we're not going to meet regulations, we're not going to justifications, hardware architecture is changing, whatever it is, we need some help with the oil side of things. The first step is to take justification that goes to a team, and that team evaluates the justification, whether or not it makes sense or not. Doesn't always pass muster. Sometimes the justification comes in, people look at it and are like, oh, that's not a category. So CI4 with the CI4 plus, you might be familiar with those. Didn't go to CJ. It wasn't enough for a category. It's just a new test that got through. There are a lot of groups that look at the justification, the proposal, the request, and the category as it is put in to go forward. API is one group. API includes IF 1509, which is a wonderful document if you're ever having trouble sleeping. It's a couple hundred pages of how the licensing system works, how category development works, how the system works. API is officially a lobby group headquartered in Washington. They own that document, they own the licensing system, they have the oversight over 1509. I'll apologize now. There's a lot of acronyms. Everybody in their own world has their own set of acronyms. I'll go through a lot of them as we go on. So BOI, VGRA is base oil interchange viscosity grade read across. It's a mouthful. I'll explain it more a little bit later, but it's a big part of category development. API is one group that goes through. That works. The test developers. These are the guys that do the nuts and bolts. So every category has a number of engine tests. If you're using an oil, you probably aren't going to be comfortable if somebody says, yeah, the viscosity's right, the density's right, the phos level's right. You want it tested so you know it's going to work in the application. There are a number of engine tests. We'll see it shortly. The engine tests are developed by individual OEMs. Those engine tests are then put through a very rigorous protocol to make sure that they're repeatable, reproducible, and they show discrimination. Because if they're not repeatable, then the values are useless. If they're not reproducible, then they're useless. If they don't discriminate between a good oil and a bad oil, then the engine test is useless. There's a lot of check marks to make sure that an engine test is accepted into the category. Piece of cake, right? No. Engines are engines. They're not controlled. They do their best to control them. They have electronic control module, they have a lot of software that goes into it, but they're engines. Durability is something that everybody is very interested in. So is fuel economy. If you want to balance between durability and fuel economy, I think people take the durability over the fuel economy. They like to have that engine last as long as possible. So we're going to test that engine for durability. Well, surprisingly, OEMs design hardware to resist wear and engine breakdown, but that's what we're trying to test in the lab. So the test developers can have a very difficult job designing tests that measure how the oil reacts within that engine itself. Make sense? Who else is helping us out? EMA, it's the Engine Manufacturers Association. That's the Caterpillars, the Cummins, the Max. Those are all the big boys. They're the ones that make the engines, that design the engines. They're the ones that develop the tests. They're also the ones that have the direct line to people like the EPA and the California Air Resources Board that set greenhouse gas emissions, that force them to change their architecture to make things better. ACC is the American Chemistry Council. Those are the technology suppliers. Those are the additive companies. Afton, Infinium, Lubrizol, Oronite. Those are the people that provide the performance packages to the oil marketers that blend everything together to give a finished oil. So they've got a big deal. They've got a big part to play in this because their technology helps with a lot of the parameters that people are looking for in the engines. If people are putting moly in to try and reduce the friction to increase the fuel economy, that's coming from an additive company. It's not coming from an oil marketer. Petro-Canada doesn't make additives. Petro-Canada makes base oils, and then we blend the additives. Get the additives from somewhere. They have an entire organization that is as complicated and as in-depth as the American Petroleum Institute. So they have a code of practice. So all the additive companies follow a code of practice. That document is several hundred pages and it's just as dry as 1509, but they're an integral part to the process. ASTM. So ASTM is the holder of all the test methods. So all the engine tests that are developed become ASTM test methods. Then ASTM, it oversees each of the individual tests. So every single engine test has a surveillance panel. And they monitor all the calibration runs, all the reference runs at all the laboratories to make sure that the engines that are installed at all the labs are running the way that they were designed to run. And if they go out of whack, then ASTM pulls them back in, does their work, gets everybody together, figures out what's going on, and gets everything back in control. And then there's limit setting that all the people take part in. And then all the other industry groups have a say in the matter. They're not as involved. SAE sets the viscosity grades. So we need to know if it's a 1540, 1030, 520, et cetera, et cetera. SAE, the Society of Automotive Engineers, they set that table on how those viscosity grades are designed. ILMA is the independent lubricant manufacturers. Those are the independent blenders. JAM is the Japanese manufacturers, and everybody gets together around the table and we all talk about it and ensure alignment. So we're all happy with everything that's going on. We're all suitably satisfied, and then we can move on with the category. If you have questions, please just shout them out. I'm not going through this. I give entire talks on category development. This is the heavy duty one. There's the light duty one. This is just to show you how everybody's kind of intertwined. So ASTM groups are kind of in orange. EMA is in yellow. APIs is the green. This is DEOAP is kind of a link between many other groups, although they're owned by and oversight. They are overseen by ASTM and the technology people, the additive suppliers. There's a lot of work that goes into category development. There's a lot of stuff. Before I got into this role, you just kind of take it for granted, right? Whether it's a starburst on the back of a 5W20 or 020 for your car, or it's a donut on anything. It's just a symbol, right? This is all the stuff that goes in behind it. Where are we today? December 1st, 2016, PC-11 came to the market. We know it as CK4 and FA4. Phase 2 greenhouse gas regulations drove this category. When the EPA or the CARB say you're going to reduce emissions by this much, and the current engines don't meet that, regardless of what the after treatment is, then you got to fix something somehow. Starts with design of the engine, which feeds into the lubricants directly. Focused on fuel economy, shear stability, and oxidative stability. That's how we got to where we are today since 2016. CK4 are the traditional grades, the 1540, the 10W30, high temperature, high shear at 3.5 centipoise. So it's a laboratory. Does everybody understand high temperature, high shear? We know these. Sorry if I'm assuming this. 3.5 centipoise minimum is the traditional grades. FA4, great idea at the time. It was, and it works really well. In an engine that's designed for FA4 oils and optimized, it works exceptionally well. It's a fuel efficient, targeted viscosity grades. Started with 1030. High temperature, high shear between 2.9 and 3.2, so the viscosity is a little bit lighter. Still at 1030. Meets that HTHS. So the FA4 oils were proven to be very good towards meeting the limits. But the oils didn't increase as demand as we projected. There was exactly one OEM that recommended FA4 oils when they were introduced to the market. Everybody know?
Detroit.
Yeah. Anybody know how many are now recommending FA4 oils? Detroit. Others are looking at it, but it's not very fast.
Although Cummins never recommend anything.
They're close. I don't know if it's officially been released yet or not, but they're close. So CK4 and FA4, API 1509 holds those. ASTM has test method 4485 that has all the specifications. So the traditional testing that's done on a heavy duty oil on top of your physicals and chemicals, high temperature, high shear, high temperature corrosion bearing test, shear stability, NOAC foam, mini rotary viscometer, and elastomer compatibility. Those are the bench tests that are run. And you can see what each of the tests measures. Shear stability is, there's a number of different ways to measure shear stability. This is the Kurt Orban test that's officially in the methodology. Just seeing how well the oil will stay in grade after mechanical wear. You run it through, there's polymers that are added into that, so you get your viscosity grades from mono grade to a multi-grade. If the polymer isn't stable, that will shear out of grade. You don't want that, right? If you start with a 1540, you want 1540, regardless of what the best grade is, you want to stay in grade. Volatility is very important because nobody wants to top up constantly. That's not great for emissions or for cost efficiencies. Foam aeration is horrible, breaks down boundary lubrication, terrible for pumps. Just minimize foam as much as possible. Sooted oil, the elastomers are listed there for the currents, and then the chemical limits. So the chemical box, as they call it, is you may have heard SAPs, right? Sulfated ash, phosphorus, and sulfur. Really important for after treatment devices, as well as some performance characteristics. So phosphorus, for example, ZDDP, zinc dialkyl dithialphosphate, is the single most popular anti-wear agent that's been in the market since the beginning of time, since Rockefeller had oil companies, and it's measured basically by phosphorus levels. So we have some engine tests. This is the stuff that a lot of people may not know. This is your education part. These are the engine tests that are currently in the category. Volvo Mac sponsors 3 tests. They developed 3 tests. The 11, the 12, and the 13. The 12, you can see what they're, I don't have to read them all, right? So there's wear tests, oxidation tests, sooted oil tests. GM does a roller follower wear test, which is a wear test, right? Again, durability is key. Caterpillar, the C13, the aeration test, and again, another wear test, the 1N. And Cummins has the ISB and the ISM, which are workhorses. They've been around for decades. They're still in production, and they're looking at, again, more wear tests. A lot going on. So, before I get to the next one, just to give you an idea, the process is when a oil is formulated, somebody has a formulation with base oil, performance package, whatever other pixie dust is thrown in to meet the specifications, goes off to get tested in laboratories. It may be in 1 laboratory, 2, 3 laboratories. There's only a handful of laboratories that run the engine tests. You get all the data together and you send it off to API, and API checks all the boxes and they issue you a license so that you can put the donut on. But all of this testing for 1 single viscosity grade for A15W40CK4 in 2016, it was about, give or take, a couple of dollars, $1 million US to do the testing for 1 viscosity grade. So if you've got a 1540 and a 1030 and you've got a good, better, best offering, conventional, semi-synthetic, and synthetic, it adds up pretty quickly.
There are so many engine tests. How long do you even take to finish all of them? I
do the testing.
One test probably will take like several months, right?
No, so from start to finish, to do all the testing is between 3 and 6 months. So we prepare quite a bit ahead of time. When they're developing an engine test, it's a balance. So you want to be able to generate repeatable, reproducible, discriminated numbers, but you want the test to finish quickly. So if you want to run a viscosity, I can put it into a laboratory and have a result back in 20 minutes. But on an engine test, it takes time to generate discriminating data, and you have to balance that against running the engine test. So the single biggest cost of running one of these engine tests is fuel. So if we're going to control everything in the engine so that we're just isolating the changes within a lubricant, we need to standardize the air coming in, We have to standardize the fuel coming in. We have to standardize all the parameters. We have to control that engine the exact same way every single time. So the fuel that's used for this is specially blended, specially designed. It's very well controlled. It's exceptionally expensive. In the $20 to $25 a gallon range. So if you're plowing through a couple gallons an hour and you're running a test for 200 hours, it adds up to credit.
Do any facilities do this in Canada? Is it like the Southwest Research Institute?
Southwest Research in San Antonio, Intertech in San Antonio are the two main ones that run the engine tests. A number of the additive companies have some of these tests. Some are qualified for licensing work.
Yeah.
Some are used as developmental engines. So they'll develop their additive technologies running these in their own shop and their facilities. So, and they're the additive companies got it all over. Two big ones are Southwest.
Yeah.
PC-12. So in mid-2021, it was 2 years ago, mid-2021, the request came in for a new category for PC-12. Surprisingly, phase 3. So phase 3, EPA and CARB regulations. The request came in mid-2021. So initial work started while people were scoping out what the category may look like. The problem is the final decision on what the limits were going to be weren't finalized until December. There is a process where EPA and CARB develop limits. They don't set the limits, it still has to go to Congress. It goes from California and the government bodies to Congress to sign off on it first. So there's a lot of back and forth in that year and a half. The final decision did come through in December of 2022. Always an improvement in environmental. Everybody's always looking for better GHG emissions. Fuel economy is part and parcel of all of that. You burn less fuel, have fewer emissions in the grand scheme of the carbon footprint. Lower SAPs, sulfated ash, sulfur, and longer drain intervals. We like longer drain intervals because there's less waste. Less waste, better for the environment. It's all part and parcel. You start to look at things holistically from cradle to grave. Yes.
So question, sorry. It may be too general too, but so when the greenhouse gas regulators and the EPA get together, so let's say the change that they made when it came to PC-11, do they get together again to measure like what did you reach, what goals, like did they reach their, do they have targets, do they measure that?
Yeah, that is.
Or is it all like?
It's outside of my area of expertise, but EPA and CARB do all of that GHG monitoring, and they're setting the limits based on whether it's a directive from the White House, Congress, the Senate, and the states, they're setting it down, or whether they're setting it and bringing it back. But at the end of the day, what we do know is that whatever CARB sets, California Air Resources Board, they're in conjunction with the EPA, and it goes to the rest of the country.
Right.
Because there isn't going to be an auto manufacturer anywhere that's going to make an engine for California and a different engine for everywhere else. So they're leading the charge. They're doing the monitoring, they're doing the setting, they're doing the negotiating and rolling it in from California.
So I was wondering if they measure their improvements, considering that what they say has that trickle down effect of all of that, like the graph showed us.
Yeah, there are a lot of graphs that'll show NOx, particulate matter, measured in their various areas and how much it's decreased over time, whether they're doing that based on the limits off of that or whether they're forcing it. We saw a lot of that when it went from regular sulfur diesel to low sulfur diesel. We saw those emissions. We've seen various after treatment devices, EGR and the SCR and DPFs, and when they get introduced They have all those nice fancy graphs, but how closely they're monitoring incremental effects,
Right.
I'm not sure. I'm sure they are. Improvement in oxidation stability and wear protection, because these are kind of the generic, this is the generic term they add to all categories. We don't want the oil to oxidize, ever. We want wear protection. We want our engine to look the exact same way at 1,000,000 miles as it did when we sold it.
There,
Yes,
in terms of the better oxidations that we need all the way of protection. You know, the current CK4R is super good already, because the truck, they run 80,000 kilometers.
Yep.
Up to 100,000. So can you imagine that the newer PC-12 will be even better? How can they do that?
so this is environmental efforts is driving the category. And they're looking for a little bit better. They're always looking for a little bit better. Whether it's a little bit or a lot will depend on the balance and the limit setting that we get to when we're closer to the end of the category. The EMA has requested updated elastomer testing. That's the seals. All the seals keep changing. You've got to keep testing to make sure you've got compatibility. If you have incompatibility, the seals are just miserable to deal with, right? So we want to make sure that all the new polymers and elastomers and seal material and everything else that's coming through is updated in the compatibility testing. ASEA is the European group that sets industry standards like API, and they're not quite aligned. Right, light duty and heavy duty is a little bit different in Europe than it is in North America and other parts of the world. We've been trying over years to align that, just try and get it a little bit closer and a little bit closer all the time so that we're getting that little bit there. Hardware availability. So with any new category, when we're looking at engine tests, the engine tests themselves, we'll talk about it a little bit later, but we're looking for the end of life. The engine tests are production model engines. They're not prototype engines. You want to have something that's representative of what's in the field. OEMs don't make engines forever. Well, Cummins makes an ISM and ISP that's been around forever. But there's a lot of engines that eventually go out of production. If you're going to go into a new category, we look at how long that category is going to last and make sure we have enough engines to test in the laboratories with those engines. So that we can keep the category going. And we're looking at redundancy because as you saw on the list, there's a lot of wear tests. How many wear tests do you need? Well, if there's a ring and liner wear test and a scuffing test, or there's different wear in different parts of the engine. So sometimes it can make sense. Sometimes it can't. If there's a redundancy, then we go through a whole exercise to see what the redundancy is, if there's correlation, if it's okay to drop the test or not, and move on from that point. Try and save a little bit of money. Q1 2027. We started in the middle of 2021. It seems like a long way away, but it's tight. So the original request was January 1st, 2027. Now we're saying Q1 2027. The last categories that we developed, PC-11 or CK4, we were designing at the same time as GF6 on the light duty side. Both categories were delayed for various different reasons, not the same reasons, not because we were doing it at the same time, but the target date is the set date. So I'd love to see it in Q1 2027, and we'll be cautiously optimistic that we can get there from here. This is kind of what the industry has started with as what the specification will look like. So you can see where there's a 12A and a 12B. Yes, there's going to be a 12A and a 12B. There are going to be two categories going forward. More OEMs are looking at the low HTHS. Promises, fingers crossed. A lot of the tests are just going to be CK4, FA4 limits carried forward, which is good news. The tough ones are T11, which is disappearing. So we need to find an equivalency for the T11. The T12, not going to make it. So we're looking at a redundancy or an equivalency. If you've got categories that are in the marketplace today, you want to try and keep those categories. I'll talk about it in a bit. There's reasons for keeping older technology in the marketplace, and it's quite important. And there's a couple new tests. There's a lot going on. This might make it break it down a little more. I'm going to apologize now. I grabbed this from another presentation. So if it says like see slide 6, I don't have slide 6. Sorry. C category and F category. These are the proposals that are out there for 2027. Still going to have the XW40s, 1540, 1040, 1030 in both categories, which is where that education piece comes in to make sure we're using the right oil and the right application. And you see XW20s now. So we're looking at 5W20s and 0W20s as part of a licensable category. Backward compatibility. Every category that's designed, we want it to be backwards compatible. We don't want to put an oil out that can't be used in an older engine. That kind of segregates the market. That makes it really difficult for people that are running the units every day to make sure they got the right oil. So backwards compatibility is crucial. C category, not a problem. On the F category, not required. Curious. So the thought process is here for PC-12, B, the F category, FA4 will cease to exist. The one OEM that's using it has agreed to do all the testing up front to make sure that the FB4, I'm assuming it's going to be called FB4, is going to be compatible in their FA, where FA4 is required. They're the only ones that really care about it right now. Which makes it a little easier for those of us that are developing the categories, because we don't have to worry about whether or not the new spec needs the old spec. We've got a fresh slate for FB4. That's a good thing. It is. It really is. You push all of the onus on the OEM and less on the people that are developing the category. Wear tests. Daimler DD13 scuffing test. That one's new. I'll show you in a second. Our good friends at Ford have 6.7 liter valve train wear test. That one's new too. That one's a challenge. I'll show you that one in a second. T12 equivalency, because like I said earlier, the T12 is going away. Bring in liner wear. Kind of an important one. But the engine is not going to make it through the category, so we need something else. People are kind of really interested in ring and liner wear. It's a big deal when it comes to durability. Soot viscosity control is tested by the T11, which is going away. We need an equivalency. We need something to replace that. We're working on it. These are the things that take a lot of time to try and develop. Chemical limits, I talk about sulfur and phosphorus and sulfated ash, that's the chemical box. We're trying to align those limits, not just between API and ASEA. We're trying to align it within EMA. Sorry, EMA is trying to align the limits. I'll show you in a second. Not all the OEMs agree on what that should look like. They've all got their own separate ideas on it. There's that nefarious tighter limits for oxidative control. Less oxidation is better. I know we don't like to make general statements like that, but oxidation is bad. Oxidative byproducts are bad. The less we can have, the better it is for the engine. So we're always trying to improve on that. And elastomers are to include the new elastomers that are being used in the compatibility. On the chemical box, the majority of the OEMs or the EMA members, like 800 ppm phos, 0.3% sulfur, 1% ash. Stable, steady numbers. Everybody's nice and happy with that. Except for one OEM, who has already set their specifications for the next generation. Because of the DPF requirements have a lower requirement for ash. That's frustrating. Now there's another OEM wants to include sodium and potassium. Sodium and potassium limits, should I say. They don't want to include sodium, they want to put limits on it. Because they like to use SCR as their after treatment. Poisoning the catalyst they found increases if you've got any sodium. So they want to put the limits in. Not everybody agrees to that. If it's only applicable to one OEM, the argument is, why should we have an industry spec if it's your problem? It's prevalent argument. Alignment is preferred, but we don't want to have a different chemical box for CK4, or not CK4, CL4 and FB4, assuming that's what PC-12 categories are going to be called. If you have different chemical limits, then you have different oils. If you've already got too many oils in the shops, you have too many oils out in the marketplace, it was already confusing trying to explain to people what one 10W30 versus another 10W30 and getting different labels, and making sure spent 6 months trying to educate everybody about CK4 and FA4 had the same viscosity, but they were different oils and a headache. The more oils we put in the market, the more confusing it becomes. So EMA is currently considering a compromise. See, EMA has to come to agreement before they bring it to the greater good. The greater good then has a discussion about it. If the engine manufacturers can't agree on it, what good is it for us? Engine tests. So I'm going to go through the two new engine tests that they're proposing for PC-12. But just a quick review of them. Resource intensive is an understatement. They are long tests. They can take some of them 1 to 2 weeks to run. You want to generate wear in a modern engine that does everything it can to resist wear. It's tough. They're very expensive, and the energy required, whether it's fuel, electricity, everything else, even just people, it's a lot. Mandate is to use engines that are in current production. There's no point running a 1952 engine on 2023 lubricating oils. There's no relevancy to the field. It makes no sense whatsoever. So we have current production models running current lubricants, working through the process. And yeah, we're looking at redundancy and end of life. So the Caterpillar 1N, they're looking at whether it's redundant. Again, too many wear tests. Let's get it out. Nice thing is you remove a test. Might be the cheapest engine test that we've run. So a little bit into there. So T11 and T12 will come to their end of life before the next category, PC-13. You can't develop PC-12 and have an engine die or end of life in the middle of PC-12 because that necessitates a new category. So they have to get it through PC-12, project how long PC-12 is going to be there, and project the end of life of the engine. T11 and T12 aren't going to make it, so they have to be replaced. The replacement tests for any of these engines, we need backwards compatibility or correlation to older categories. So CH4 is the oldest category that is current it is still a requirement where regular sulfur diesel is used. China is the single biggest market for CH4. Doesn't really affect us very much, but it affects us as an oil market. And there are some government documents. So there's actual approvals in individual countries that call out CI4. If we no longer have CI4 as a category, and you can't license something to CI4, then by law, that country can't import the oils into them. That becomes a problem. Now you have to get people like API to work with governmental agencies to update their documentation so that they can remain legal in their own countries. I'm not a gearhead. I'm a chemist by trade. My minor is in microbiology. It's not in mechanical engineering. You guys will probably know a lot more about this stuff than I do. But there's a DD13 engine. I'm not going to be able to answer all the questions you might have on this. But Detroit, Daimler was concerned about scuffing. The scuffing is a type of wear. When we talk about wear, you can have adhesive wear, you can have abrasive wear, you can have scuffing wear. They're all different mechanisms. They all work a little bit differently. They all react a little bit differently. They're all controlled a little bit differently. We all think of wear as abrasive wear. Particles of soot or contaminants, little pieces of metal, breaking the boundary lubrication, get metal and metal contact, and you get the wear. That's abrasive wear. This is scuffing, a little bit different. But they're looking at, well, you can see the new liner and the scuffed liner. You see all the specs here. This is the part, the uncoated top ring is the part that is a little bit caused a lot of discussion in the industry. You want a production model engine. Nobody's buying an engine with an uncoated top ring. That's not right. You have to create wear. You have to create the phenomenon in the engine while using a production model engine. So you have to accelerate the process somehow. Because if you just run the engine in a laboratory and wait for scuffing wear, you'll be waiting forever. We won't license a thing ever. It'll take years before we get to that point. So modify the engine to a point that everybody can hold hands and agree to. Adding the uncoated top ring helps accelerate this process. During the test, we're looking for, I run a test. You need to know how to turn the thing on, but during the test, they're looking for iron levels and crankcase pressure. So when you get wear problems and you increase oxidation, you increase wear metals, you increase problems within the engine, crankcase pressure changes. We're monitoring that as well as the levels of iron. After the test, you see the top ring, you see the liner. It's just a visual inspection. Basically a pass fail, yes or no. Yes, it scuffed, or it didn't scuff. How much weight loss is off the ring? Micrograms, but there's a limit to it. Because honestly, anywhere is bad. So you want to minimize that. That's the Daimler scuffing test that's been proposed for this category. Ford found a problem in one of their engines with some increased wear in the valve train. Started with the 2019 Power Stroke. We'll get into why that's a problem, but this is where they've started. They've adjusted a few things to try and speed up the process, but they're looking at wear specifically on the valve train. There is a question with this test, whether it's specific to a Ford design or whether it's an actual wear phenomenon. That's still being decided in industry. Right now, it's accepted into the category, but that can change. What's a valve train wear mechanism? Side view coming down the cylinder head. As the cam rotates, follower push rod, rocker arm goes. As you get wear here, the adjuster changes, so you continue with that gap, but eventually the adjuster runs out of adjusting capability, in which case you get noise. Get that ticking noise? Anybody owned a Ford with a ticking noise? Not with this engine, it's a different engine, but that's what happens. So you get a noise. And that noise is metal on metal, which is bad. We don't want that. So we're trying to reduce that. The lubricant can help with that. The lubricant can help protect the parts as it's going through that process. Different picture of it here. Oh, that's this. Sorry, so this is the other picture of it here, right? So the camshaft, the lash adjuster's down here, and the wear is occurring. The push rod meets the rocker arm. So the critical parts, there's the rocker arm, the push rod, and the follower shaft. The parts that are most problematic are the push rods. I've got a picture of it on the next slide. The push rods and the rocker arm on this side where the push rod meets the rocker arm, that's where the wear is occurring. You should be able to see it there. So you can see the little footballs that show up on the rocker arm on the end of the push rods. It's just not what we want to see in an engine. It's just bad, right? That's where. That's a fairly unmodified engine that's taken that kind of abuse and showing that kind of wear over a period of however long it takes to get there. These are field samples. Any questions? Those are the two tests. So those two tests alone, the valve train test that's being recommended, I think runs $125,000 to $130,000 to run a test. And the DD13 is just a little bit more than that. They're long tests. They're very expensive because they're between 200 and 300 hours per test. And they're going through gallons of fuel an hour. Next steps. Continue monitoring test developments. That's not good. 2019 engine isn't going to make it through the category. So Ford did all this work on the valve train wear test, developed a nice test, and then they changed their production schedule. So the 2019 model that it was originally designed on isn't going to last through PC-12. Upgraded to the 2023 model. It's a new model. It's a very similar 6.7 liter power stroke, but it's not exactly the same. So we have to upgrade it and repeat to validate the testing that was done in the 2019 with the 2023 model, which means running more tests, which is expensive and time consuming. But we have to make sure that if there's an anomaly when we move to 2023 model, if there's an anomaly in the testing, we have to find out why there's an anomaly in the testing and what we can do to fix that testing. Replacement for the T11, so talked about that already, and the equivalency of the T12. Next steps. So I talked about repeatability, reproducibility, and discrimination. And there's a lot of acronyms up there. So PM is precision matrix. What we do is once a test developer has an engine, you bring it to the industry, they say, here's our engine test. We like it. It's ready to go. But we design a precision matrix. which is just what it sounds like. It's a matrix of tests designed to determine the precision of the test. BOI VGRA matrices is base oil interchange base viscosity grade read across. Viscosity grade read across is extremely important. So what that does is we design a matrix up front for viscosity grade read across. And we test 10 W30s, 5 W30s, 15, whatever we decide to do, and we look for directionality. So that we are able to run a 15 W40, and if we know that 15 W40 passes the test, we can say because all the stuff we get up front, all the other viscosity grades will pass. So we're reading across results from 1540 to all the other viscosity grades. Saves a lot of time and a lot of money, and that's good for everybody. Some tests, like wear tests, will test on the latest viscosity grade, because wear generally is directionality to heavy. Your wear numbers, you get better wear protection as your viscosity increases. Thinner oils can pass, and thicker oils are pretty much guaranteed to pass. But you have to generate data for that. You can't just come in and say, we used to, 20 years ago, before my time doing this work, we used to have OEMs come in and they'd say, yes, we bless this as wear in this direction. And then there was one anomaly once, and that all stopped. Now it's 100% data driven. You can't have a read unless you have data to prove that read. Just too much money at stake. So we design these matrices, base oil interchange. So if you've got group 2, group 3 base stocks, if you have group 3 base stocks and you want to substitute with another group 3 base stock, we do that up front to allow for flexibility in the industry. Again, that saves money, time, resources for everybody involved. We have to look at BOI and VGRA for existing tests. So if we're looking at an ISM, there's reads today for 1030 to 1540. But the new category is going down to 20 grades. So we can develop those reads now. And if we don't develop the reads, it's fine, category goes ahead. But everybody has to test every single product of that viscosity grade. So it backs things up. I think I talk about test requirements. So for PC-12, when I say we have to finalize the test requirements, I make it sound easy. But that's those tests that we were talking about earlier, not only the engine tests, the correlation back to the old engine tests, the new limits, it's finalizing the tests, the requirements and the limits. Once all of that's done, there's a technology demonstration period called tech demo. That gives the additive companies time to test their technologies against the proposed final specifications. It's important because there has to be a level playing field for everybody. Everybody has to be able to demonstrate that their technology can meet the specifications. What's even more important is what they call a mandatory waiting period. Tech demo period takes anywhere from 9 to 12 months. The mandatory waiting period is again between 9 and 12 months. Once the technology demonstration period is finalized, set the limits, you set the specs, and you go into waiting period. The waiting period is designed to comply to anti-competitive legislation. Every single company and every single oil that has a license requested has to have a chance to have that license granted before the first licensing date, so that everybody gets a level playing field. If there's one oil that's in the queue Well, the first date comes out, then that's anti-competitive legislation. That is, it's government, yeah. We do that in order to meet the government mandates, but it's all about the anti-competitive legislation. This is why these categories take a while to develop. And we gotta commercialize it. And commercializing a product launch, although we get a lot of stuff going up ahead of time, it takes time. You gotta turn over inventory, you've gotta get all new marketing collateral, you gotta get all the labels, you gotta get all the packaging, and you gotta turn over the inventory. And that's a balancing act as well. It's not bad in major metropolitans where the product is turned over pretty quickly. Some of the remote locations, you've got to make sure that you've got time to get that old product out of the system. Oh, that sucks. Q2 of this year, EPA has been talking about a new announcement. Model year 2030s. So we're looking at PC-12 in Q1 2027 for model year 2027s. And there is a non-zero chance that EPA will come out with a new regulation for model year 2030s. Which is 3 years after that. Could be tight turnaround. That's it. That's a lot. Is it a lot? Is it too much? Is it not enough?
Just right.
Perfect. Questions?
I got one, just about the DD13 stuff test.
Yeah.
When they do some of these engine tests, do they do like an engine break-in period before they begin the test? Like, because they have the special uncoated top ring, so would they do a break-in with that ring, then disassemble and weigh it, reassemble and then do the test, or do they start the test without breaking it?
Yeah, the engines are generally broken in for a period of time. The first step, once an engine gets on a test stand and it's hooked up and everything, it's calibrated. So they run a calibration run. Then they'll run a reference oil. Then they'll run a second reference oil. Then they'll run candidate oils. Then they'll run another reference oil. And then the engine test manufacturers, the engine test developers have set a number of runs that are permitted in between reference oil tests. But those parts are disposable, so the ring and the liners, they'll come out, right? They'll get either replaced or rebored, rehoned. They have processes for that as well. They try and standardize everything, and any little thing like breaking it in, weighing everything, doing whatever they need to do, and then they're doing the same thing on every single test.
Awesome. Thanks.
And it becomes a problem. You know, it brings up another point. So rings and liners are made in batches. So they might get 2,000 rings and liners. But when those are, when they're finished, they get another batch in. They have to correlate the new batch to the old batch. So it's another set of work that goes through to make sure that the repeatability and reproducibility and precision hasn't changed as time goes on. Yeah.
If you're seeing new additives coming out that will go into the new oil formulations to reach these goals.
So these goals for PC-12, there will probably be a step change in technology, like we saw from PC-10 to PC-11. There was a technology step change. I would expect, based on the GHG numbers and some of these tests that are being proposed, the step change isn't going to be as large, but I think it'll be a new technology that will come in. So we'll see some new, I don't want to say new chemistry, maybe a modified form of the chemistry.
I recall the introduction of monoxide rare additive that came out, and that information came out in the field very well. And all of a sudden, everybody with Caterpillar said, hey, our engines are excessive. Because they started producing it was the top rated moly.
Right.
Base metals, and then it's, oh, well, the oil, so it's cause for alarm right across North America. When that oil is, so.
Yeah, there's been a number of examples like that over time. That's why we continue to encourage all the EMA, all of the engine manufacturers to take part in things. Primarily in on-road categories. These aren't off-road categories, although Caterpillar uses them. Caterpillar used to have on-road, now they're solely off-road. They're still part of this, but we don't have other off-road manufacturers that participate in this that still use these products. So we do get participation from John Deere. They're part of EMA. But not all of the off-road people are part of the development, which can cause problems. When not everybody's sitting around the table, you don't know of all the problems until it gets into industry and into the market, and then suddenly something happens that's a little bit wonky. So hopefully. Anything else? Good. Thanks, everybody. I appreciate your time. Appreciate the invitation.
Thank you very much. And that was very interesting.